So in the previous lesson we saw the fundamental concept of variables. In this lesson we are going to see data types. Actually, value type variables can be assigned a value directly. The value types directly contain data. Some examples are integer, as you can see, we will analyze it later. Could be character, could be float, which means that we store numbers, we store alphabets, and floating point numbers respectively. So we can, when you declare an integer type, the system allocates memory to store the value. So in this table we will see the most common value types that you will meet in all the programming languages. You will meet these data types actually in C, in C#, in Java, in JavaScript, in Angular, in Google Flutter, in every language. So it is important because at the core of any program are variables. Variables, as we saw, are where the dynamic information is stored. And actually, when you type your name into a web form and send it, your name is a variable. So not all variables are the same though. In fact, there are many different types of variables that nearly every programming language has. So let's look at a small selection of them, the most used, and also let's see their short names. The first one data type is bool, which means that we have a variable to represent true or false, or it could also mean 0 or 1, or it could mean on or off. So this is the simplest data type and commonly used. Actually, it is used as we say a flag in the programming. It could have either true or false, either 0 or 1, represents the Boolean value, and the default value, if we are not going to assign a value in this variable, is going to be false. The second one is int, as we call it, which means that it's actually an integer type, a whole number, whole meaning there are no digits after a decimal point. So for example, 65 would be a valid integer, 65.728 would not. The default value is 0, and this is the range of this data type, because it will use, as we said previously, actually when we declare an integer type, the system allocates memory to store the value, and the memory is very specific according to the data type. So we can use integer type if the integer could be from minus 2 billion to plus 2 billion approximately. The third one is what we call char. That means that is actually a character, and this is a single character, like it could be a letter or a digit or even a symbol. You don't often create single character variables, but they are the core of the language, so you need to know what they are. Actually, this is the range in the Unicode system, and the default value is the escape character 0. So actually the next one has to do with floating point numbers, or as we will meet in every language, in almost every language, it is represented as float. Actually, it is a number that may have digits after the decimal place. So 65.0 is technically a floating point number, even though it could be represented just as easily as an integer as 65. Actually, it takes more memory to store a float, which is why there is a distinction instead of just creating a number data type. So it has more memory than integer, and as you could see, also the range is much bigger. And the default value, if we don't assign any value in this variable, would be 0.0. So the next data type is actually a double data type. As we could see here, we had a floating data type that is a 32-bit single precision floating point type, which means it's a huge range between this one, but also we could have an even larger number, and this number is represented as double data type. It's also actually a number that may have digits, a lot of digits after the decimal place, more precisely as you think. So technically is also a floating point number with much more double, actually as it says, double precision floating point type. So the range is much bigger. Also the default value is 0.0. Finally, string means that there is a string of characters of any length. So for example, as we said in the previous example, our name on a web form, our name would be stored as a string variable. So string is a set of characters of any length. For example, we could say that if we say that name could have the value Smith. So this is a variable that we will say that it's a string, which means that it could have string values. So moving on, programming languages can be divided into those that are strongly typed and those that are weakly typed. Actually, a strongly typed language requires that you explicitly declare what type of variable you are creating, and they get very upset if you start trying to do things with them that you shouldn't. For example, a strong type language would give you errors if you try to add an integer and a string together. So a weakly typed language, on the other hand, would not have any problem and give it and actually will give you a warning, but your program will compile and run. So it might seem at first like weakly typed languages are easier to write, but they can often result in curious errors and unexpected behavior that take you a while to figure out. So let's go on and see the difference between assigning versus testing for equality. So in the first state we have a equals 5 or a equals 5. Actually, the first one has to do with the assignment. if we would like to tell the difference, the first is known as assignment. It means that we assign the value of 5 to variable a. So we are setting the variable value. While the second statement is the one of equality. So it actually means, is a actual to 5? And the answer given back to you would be actually a Boolean value. It could be either true or false. You will see how this can mess up your programs in later lessons. So in the first one, we assign the value 5 to variable a, while in the second one, we check if the value is equal, if the value of the variable a is equal to 5. If this was a program, then this would be true, because in the previous command we assigned the value 5 to the variable a. Thank you very much, and looking forward to seeing you in the next lesson.